Well, good afternoon, class. Hope you're ready for the last month of school. One more exam to go for those of you getting dual credit. And so the last exam's a little bit longer, and what it does, it's basically on solutions, but it's 40 points, but 20 points is going to be on our periodic table, ionic compounds and covalent compounds, and naming. So I thought I'd spend a few minutes here refreshing our memories on the periodic table and ionic and covalent compounds. All right. So periodic table, remember this line right here, it will separate the, that's right, metals to the left and nonmetals to the right. If it's on the line, it's a metalloid. If it's a metal, of course, it's going to have a positive oxidation number, okay? Because, if you remember, everything in group 1, it's got one electron in its outer shell, its valence is 1. Right? So it will lose one electron, it'll become +1. Everything in group 2, remember, it's going to have a 2+ charge because it has 2 valence electrons it loses. Remember here, I got 2 electrons here, but in reality, it's more complex. Okay, so you have this cheat sheet, and the good thing for you guys on the last exam, you can use it. All right, it's open book. Okay, so you can look those oxidation numbers up. And of course, over here, here's 3 electrons in the outer shell, or 3 valence electrons, 4, 5, 6, 7, and then 8. Of course, those are non-reactive, those noble gases, because their outer shells are filled with electrons. All right, just a little trivia here. Group, the halogens here, group 7A. If you take 8 away from that, that'll give you its oxidation number, or -1. Okay, take 8 away from these two groups, it'll give you their oxidation number. Okay, a little trivia there. But that should all be reviewed for you. So that's all well and good. Okay, make sure you remember how to name ionic compounds and how to put them together. Remember, the sum of the oxidation numbers equals 0. Okay, so if you have sodium with a 1+ charge combined with oxygen with 2-, remember it's going to be Na2O. Alright, so just refresh your memory on that. Naming compounds, remember, if it's binary, okay, if it's ionic compound where there's transfer electrons, remember ionic is between metals and nonmetals. It's always the full, the positive, root of the negative, then IDE. So sodium and oxygen would be sodium oxide. Alright, if you get something like this on the test where you have, hopefully you can see this, you have FeO, and then also you could have iron also combines with oxygen, Fe2O3. Alright, you can do it both ways because iron has 2 different oxidation numbers. Okay, it's located here. Look at your chart, it can either be +2 or +3, but you can figure it out from looking at it, right? So oxygen is always going to be -2. Alright, so if it combines in a 1-to-1, that's got to be a 2+. Over here, Fe2O3, which is rust. Alright, well, 3 oxygens, 3 times 2 is -6. Okay, so that's a 2, so this would have to be a 3+. Alright, so you guys can figure that out. Make sure you know how to name those binary compounds. If you have a polyatomic ion, again, you don't have to memorize them, but you have memorized them because you're good students. Okay, sulfate, what is it? That's right, SO4 2-. You guys missed this. Sulfite, SO3 2-. What do we got here? Ammonium, there's a positive one. NH4 with a plus. Hydroxide. Okay, hydroxide, that tells you it's going to be a base, and it's the simplest one, just OH. Okay. Nitrate, cheaper than day rate, but nitrate, -1. Permanganate, a little tougher, MnO4. Phosphate, PO4, and this one has that 3- charge. And then see if you can get carbonate. Of course, carbonate is CO3 with a 2- charge. But again, you guys kind of luck out. You don't have to memorize them, because just have that the sheet with you when you take the exam, and things will be good for you. All right. Also, covalent bonds. Okay, remember covalent bonding is when you have molecules form between nonmetals. All right, so if that first element, or they're both nonmetals, the first element's a nonmetal like carbon, nitrogen, oxygen, they're going to be molecules. Okay, and remember covalent bonds, you have a sharing of electrons. All right, so if you guys remember doing Lewis structures, remember Lewis structures is when you write in the valence electrons. So here we have CH4, which is methane. That's what we've been burning all year in our Bunsen burners, CH4. All right. So we'll put carbon as the central atom. It's got 4 valence electrons like that. 1, 2, 3, 4. Combines with 4 hydrogens. All right, so that would be your Lewis structure there. The carbon's happy because it's got 8 around it. Okay, so sharing is like having. So that's all good. All right, so in this case you have methane. Each of these bonds is 2 electrons. Okay, you can also get double bonds. Like oxygen, it's a remember it's a diatomic element. Okay, it's got double bond, so they're actually sharing 4 electrons. And then you can get nitrogen, which is a pretty stable molecule, because it's triple bond. Okay, so it's actually, if the triple bond, you got 2, 4, 6. You got 6 electrons you're sharing there. All right. So just make sure you go through the naming. We're going to give you a little reference sheet on that naming. Ionic compounds, covalent compounds, and you do that. Write formulas. You'll be great for the test.